Okay, so once again, I think that your classmates are ready to discuss about the sampling techniques, no? So it would normally be impractical to study a whole population, right? Because, for example, if you want to know who is the possible winnable presidential, how do you call this one? Wait. So, for example, if you want to study the winnable presidential this coming 2022, so it's too hard naman for us to get the entire populations of the Philippines, right? So, what we are going to do, of course, is when doing a questionnaire survey, so sampling is a method that allows researchers to infer information about a population based on results from a subset of the population without having to investigate every individual, as I mentioned earlier, no? Reducing the number of individuals in a study reduces the cost and workload and may make it easier to obtain high quality information. But this has to be balanced against having a large enough sample size with enough power to detect true associations. No? If sample is to be used by whatever method it is chosen, it is important that the individuals selected are representative of the whole population. No? This may involve specifically targeting hard-to-reach groups. Let's say, for example, as I mentioned, if the electoral rule for a town was used to identify participants, some people such as the homeless would not be registered and therefore excluded from the study by default. And I think there are several different sampling techniques available, no? And they can be subdivided into two groups. No? Even we have strategic, stratified, random sampling, but this sampling techniques is only subdivided into two: the probability sampling and non-probability sampling. No? Of course, to give us more data or information related to the topic, no, let us all welcome our presenter. Go ahead.
Together with Rolando Arbues, reporting the rationale and technique in sampling. Instead of contacting every person in the population, researchers can answer most questions by sampling people. In fact, sampling is what the Philippine Statistics Authority does in order to gather detailed information about the population, such as the average household income, the level of education people have, and the kind of work people do for a living. But what exactly is sampling and how does it work? At its core, a research sample is like any other sample. It's a small piece or part of something that represents a larger whole. So, just like the sample of glazed donut you eat at Krispy Kreme or the double chocolate brownie ice cream you taste at the ice cream shop, behavioral scientists often gather data from a small group or a sample as a way to understand a larger whole or a population. Even when the population being studied is as large as the Philippines, about 110 million people, researchers often need to sample just a few thousand people in order to understand everyone. Now, you may be asking yourself how that works. How can researchers accurately understand hundreds of millions of people by gathering data from just a few thousand of them? Your answer comes from Valery Ivanovich Gilvenko and Francesco Paolo Cantelli. Gilvenko and Cantelli were mathematicians who studied probability. At some point during the early 1900s, they discovered that several observations randomly drawn from a population will naturally take on the shape of the population distribution. What this means in plain English is that as long as researchers randomly sample from a population and obtain a sufficiently sized sample, then the sample will contain characteristics that roughly mirror those of the population. Why is sampling important? First is practicality. In most cases, a population can be too large to collect accurate data, which is not practical. Samples offer a representation of the whole population if sampled accordingly. Samples allow researchers to collect data that can be analyzed to provide insights into the entire population. Next is it offers urgent data. When it comes to research, the amount of time available can be a defining factor for a study. A sample provides a smaller set of the population for review that delivers data that is useful to represent the whole population. Surveying a smaller sample as opposed to the entire population can save precious time for researchers and can offer urgent data. Next is cost effective. The cost of conducting research is often a parameter for the study. Researchers must do the best with the resources they have at hand to carry out a survey and gain accurate insights. Surveying a representative sample of a population is cost effective as it requires fewer resources like computers, researchers, interviewers, servers, and data collection centers. Next is accuracy of representation. Depending on the method of sampling, research conducted on a sample can be accurate with lesser non-response bias than if performed by the census. A sample that is selected using the nonprobability method is an accurate representation of the population. This data collected can be used to gather insight into the whole community. Inferential statistics. Inferential statistics is a process by which representative data is used to infer insights about the entire population. Data collected from a sample represents the whole population. Inferential statistics can only be obtained using data samples. At times, a sample is more accurate than a census. A census of an entire population does not always offer accurate data due to errors such as inconsistency in responses or non-response bias. A carefully obtained sample, however, does away with this bias and provides more accurate data that adequately represents the population. Last is manageable. Sometimes collecting an entire population of data is near impossible, as some populations are too challenging to come by. In this case, a sample can be used to represent the study as it is feasible, manageable, and accessible. The population is the entire group that you want to draw conclusions about. In research, population is defined as a whole set of elements that all qualify as standard parameter. In research, population does not necessarily refer to the human population. Instead, it refers to any parameter of data that possesses a common trait. For example, it can be the total number of buildings in a city or the total number of shoe shops in an area. The sample is a specific group of individuals that you will collect data from. It is a subset or a smaller group of a population or a target population. Every study has an inquiry, and in order to answer it, a sample of a population is taken and studied. The sample is meant to be representative of the population and is meant to derive insights on the population as a whole. Used because oftentimes it is extremely difficult or impossible in some cases to study a whole population. Here's a table differentiating population from a sample. Population. The measurable characteristic of the population, like the mean or standard deviation, is known as the parameter. Whereas in the sample, the measurable characteristic of the sample is called a statistic. Population data is a whole and complete set. The sample is a subset of the population that is derived using sampling. A survey done of an entire population is accurate and more precise with no margin of error except human inaccuracy in responses. However, this may not be possible always. A survey done using a sample of the population bears accurate results only after furthering factoring the margin of error and confidence interval. The parameter of the population is a numerical or measurable element that defines the system of the set. The statistic is the descriptive component of the sample found by using sample mean or sample proportion. To summarize, although population and sample are two different terms, they both are related to each other. The population is used to draw samples. To make statistical inferences about the population is the primary purpose of the sample. Without the population, samples cannot exist. The better the quality of the sample, the higher the level of accuracy of generalization. Contemporary issues in sampling. These are Data Privacy Act and contracting out surveys. Surveying is the act of getting the answers from the research queries from the survey participants. The questions raised may be simple or complex, decisive, controversial or not, and the researchers must respect the answers of the participants and protect them from researchers' personal opinions which may be different or opposite from theirs. To ensure this, the identity of the participants must be withheld and kept with strict confidentiality. Often, names are replaced with codes or numbers to hide the participant's identity from the readers of the research. This confidentiality is now strengthened by the Data Privacy Act, carrying stiff penalties for those researchers or data handlers who mishandle the personal data of the research participants. An outside contractor can be utilized in carrying out the sample survey. These contractors may utilize their own methods in data gathering or in using their own sampling designs. Issues of reasonableness, like if their methods are excessive or unnecessary, inadequacy, like if their methods are too simple or limited, can be an issue if communication is poor. At the onset, it must be clear and agreed upon by both parties what methods, sampling designs are to be utilized in this case. Factors in determining the right sample size. For any sample design, deciding upon the appropriate sample size will depend on the five key factors. It is considered important that these factors, when taken into consideration together, achieve the right balance and ensure that the sample objectives are met. First is margin of error. This is a measure of the possible difference between the sample estimate and the actual population size. No estimate taken from a sample is expected to be exact. Inference to the population will have an attached margin of error. The better the design, the less margin of error and the tighter the precision, but in most cases, the larger the sample size. Next is amount of variability. The standard deviation is the most usual measure and often needs to be estimated. The amount of variability in the population, like the range of values or opinions, will also affect accuracy and therefore the size of sample required when estimating a value. The more variability, the less accurate the estimate and the larger the sample size required. Next is confidence level. It is the certainty required that the population figure is within the estimate and its associated precision. The confidence level is the likelihood that the results obtained from a sample lie within the associated precision. The higher the confidence level, that is more certain you wish to be that the results are not atypical, the larger the sample size. It is quite common that samples use a 95% confidence to provide forceful conclusions. However, if the goal is just to seek an indication of a likely population value, a lower level such as 90% is acceptable. Next is population size. It is the total number of items in the population. Population size does not normally affect sample size. In fact, the larger the population size, the lower the proportion of the population that needs to be sampled to be representative. It is only when the proposed sample size is more than 5% of the population size becomes part of the formula to calculate the sample size. The effect is to slightly reduce the required sample size. Last is population proportion. It is the proportion of items in the population displaying the attributes that is being sought. If seeking to sample for attributes as opposed to the calculation of an average value, the proportion of the population displaying the attribute being sought to identify is the final factor for consideration. This can be estimated from the information that is known about the population. For example, proportion of hospital who consider long waiting lists in COVID admissions to be a problem. Here's a table showing the effect of survey values on the accuracy of its results. When the population size is increased, the accuracy of the survey decreases. But when the population size is decreased, the accuracy of the survey increases. When the sample size is increased, the accuracy of the survey increases. But when the sample size is decreased, the accuracy of the survey decreases. When the confidence level is increased, the accuracy of the survey increases. When the confidence level is decreased, the accuracy of the survey decreases. As to the margin of error, when it is increased, the accuracy of the survey decreases. But when the margin of error is decreased, the accuracy of the survey increases. Here's a general guide and sample sizes. For descriptive research, for population of 500 and below, 20%. But for a population of more than 500 to 1,000, it would be 10%. For experimental research, 30 per group, but no less than 15 per group. Ex post factor or causal comparison group, 15 subjects per research. This is according to Sevilla et al.
Next on the report would be the different types of sampling. There are two types of sampling, and these are random and non-random sampling. Random sampling occurs when a researcher ensures every member of the population being studied has an equal chance of being selected to participate in the study. Probability sampling involves random selection, allowing you to make strong statistical inferences about the whole group. Importantly, the population being studied is not necessarily all the inhabitants of a country or a region. Instead, a population can refer to people who share a common quality or characteristic. So, everyone who has purchased a Toyota in the last 5 years can be a population. So can be the registered voters in a city or the college students at a university. A population is a group that researchers want to understand. In order to understand a population using random sampling, researchers begin by identifying a sampling frame. A sampling frame is a list of all the people in the population the researchers want to study. For example, a database of all globe or smart landline and cell phone numbers in the Philippines is a sampling frame. Once the researcher has a sampling frame, he or she can randomly select people from the list to participate in the study. However, as you might imagine, it is not always practical or even possible to gather a sampling frame. There is not, for example, a master list of all the people who use the internet or the people who purchase coffee at Starbucks. Nevertheless, there are very good reasons why researchers may want to study people in each of these groups. Next would be the non-random sampling. When it isn't possible or practical to gather a random sample, researchers often gather a non-random sample. A non-random sample is one in which every member of the population being studied does not have an equal chance of being selected into the study. Non-probability sampling involves non-random selection based on convenience or other criteria, allowing you to easily collect data. Because non-random samples do not select participants based on probability, it is often difficult to know how well the population represents the population of interest. Despite this limitation, a wide range of behavioral science studies conducted within the academe or an industry or by government rely on non-random samples. When researchers use non-random samples, it is common to control for any known source of sampling bias during data collection. By controlling for possible sources of bias, researchers can maximize the usefulness of their data. Under the probability random sampling methods, there are four types. These are the simple random sample, the systematic random sample, the stratified random sample, and the cluster random sample. Simple random sampling ensures that every member of the population has an equal chance of selection. It produces defensible estimates of the population and sampling error, resulting to a simple sample design and easy interpretation. However, it needs complete and accurate population listing and may not be practical if a countrywide sample would involve lots of audit visits. To conduct this type of sampling, you can use tools like a random number generator or other techniques that are based entirely on chance. Example, if you want to select a simple random sample of 100 employees of company X, you assign a number to every employee in the company database from 1 to 100 and use a random number generator to select 100 numbers. Systematic random sampling is similar to simple random sampling, but it is usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. This makes it easier to extract the sample than a simple random sampling, and ensures cases are spread across the population. Example of this application would be all employees of the company are listed in alphabetical order. From the first 10 numbers, you randomly select a starting point, say number 6. From number 6 onwards, every 10th person on the list is selected. Thus, 6, 16, 26, 36, and so on, until you end up with a sample of 100 people. However, systematic random sampling can be costly and time-consuming if the sample is not conveniently located, and it cannot be used where there is periodicity in the population. Because if you use this technique, it is important to make sure that there is no hidden pattern in the list that might skew the sample. For example, if the HR database groups employees by teams, and team members are listed in order of seniority, there is a risk that your interval might skip over people in junior roles, resulting in a sample that is skewed towards senior employees. Stratified random sampling involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. It ensures units from each main group are included and may thus be more reliably representative, and it reduces the error due to sampling. However, Selecting the sample is more complex and requires good population information, and the estimates involve complex calculations. To use this sampling method, you divide the population into subgroups called strata based on the relevant characteristics such as gender, age range, income bracket, or job roles. Based on the overall proportions of the population, you calculate how many people should be sampled from each subgroup. Then you use random or systematic sampling to select a sample from each subgroup. Example, if a company has 800 female employees and 200 male employees, and you want to ensure that the sample reflects the gender balance of the company, so you sort the population into two strata based on gender. Then you use random sampling on each group, selecting 80 women and 20 men, which gives you a representative sample of 100 people. Cluster random sampling methods also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. If it is practically possible, you might include every individual from each sampled cluster. If the clusters themselves are large, you can also sample individuals from within each cluster using one of the techniques discussed earlier, and this is called multi-stage sampling. This method is good for dealing with large and dispersed populations, but there is more risk of error in the sample as there could be substantial differences between clusters. It is difficult to guarantee that the sampled clusters are really representative of the whole population. An example of this application is when a company has offices in 10 cities across the country, all with roughly the same number of employees in similar roles, and you don't have the capacity to travel to every office to collect your data. So you use random sampling to select 3 offices, and these are your clusters. There are 4 types of non-probability random sampling methods, and these are convenience, voluntary response, purposive, and snowball. In these techniques, the units that make up the sample are collected with no specific probability structure in mind. The selection is not completely randomized, and hence the resultant sample is not truly representative of the population. Convenience sampling is a specific type of non-probability sampling method that relies on data collection from population members who are conveniently available to participate in a study. Thus, some regard this as availability sampling. It is a type of sampling where the first available primary data source will be used for the research without additional requirements. In other words, this sampling method involves getting participants wherever you can find them and typically wherever is convenient. In convenience sampling, no inclusion criteria identified prior to the selection of the subject. All subjects are invited to participate. The advantage of this sampling method is that data is readily available, and the larger the group interviewed, the more information is gathered. However, sample results cannot be extrapolated to give population results, and it is prone to volunteer biases. Voluntary response sampling is similar to convenience sampling. A voluntary response sample is mainly based on ease of access. Instead of the researcher choosing participants and directly contacting them, people volunteer themselves, like for example by responding to a public online survey. Voluntary response sampling is used to provide illustrative examples or case studies. Its normal application is for small samples from a population that is well understood, and there is a clear method for picking the sample. Voluntary response samples are always at least somewhat biased. as some people will inherently be more likely to volunteer than others. Example, you send out the survey to neighbors who drive, and a lot of neighbors decide to complete it. This can certainly give you insight into the topic, but the people who responded are more likely to be those who have strong opinions about the traffic situation. So you can't be sure that their opinions are representative of all drivers. Purposive sampling, which is also known as judgment sampling, involves a researcher using their expertise to select a sample that is most useful to the purposes of the research. It is often used in qualitative research, where the researcher wants to gain detailed knowledge about a specific phenomenon rather than make statistical inferences, or where the population is very small and specific. An effective purposive sample must have clear criteria and rationale for exclusion. For example, if you want to know more about the opinions and experiences of drivers of a Toyota brand in your community, so you purposely select a number of Toyota drivers in order to gather a varied range of data on their experiences with the Toyota brand. This can lead to biases, however, as they may be loyal customers of Toyota over other car brands. Snowball sampling is when initial participants refer the researcher to another potential participant. It is useful for cases where participants can be difficult to locate or identify, or for studies involving a novel trend and only a few participants are into that trend and may know each other. However, the researcher is also limited to only those known by the initial participants. Snowball sampling is called snowball sampling because, in theory, once you have the ball rolling, it picks up more snow along the way and becomes larger and larger. Snowball sampling is a non-probability sampling method, and it does not have the probability involved with, say, simple random sampling. Rather, the researchers use their own judgment to choose participants.
Computing the sample size. There are many different formulae being used by researchers for different uses. All these types have different purposes and will use a set of required data. There's a formula that necessitates the determination of z-score, the standard deviation among others. Generally, the common data that is needed are population size, the margin of error, and confidence level. The formula on the right may be the simplest and widely used. It is called Slovin's formula. As you can probably see, there are fewer elements of data being used. Slovin's formula requires from the researcher to know the population size and the margin of error. By inputting the formula in Excel and other computing tools, one can come up with the sample size. The formula is total population or capital N divided by 1 plus the product of the total population or capital N and the margin of error squared. Slovin's formula is used when the researcher has no idea about a population's behavior.
A sample illustration of the Slovin's formula, where we have a total population represented by capital N of 1,250 and a margin of error of 5%. Substituting the values to the formula, we have 1,250 over 1 plus 1,250 multiplied by 5% squared. We will have 1,250 over 4.125, giving us a sample size of 303.
Expect surveys to pop left and right as we near the upcoming national elections. You may wonder how the survey companies came up with the sample size in their election surveys. They may use a different formulae, but the common formula used for this purpose is the one on the right. It is quite a complicated formula, but it results to a very high accuracy. The variables are replaced with data of 62 million eligible voters using a 2% margin of error at 95% confidence level and population representation of 50% to come up with a sample size of 2,401 survey participants. The question now is, have you been part of the 2,400 participants in the survey or those conducted in the past?
Is there a continuation or what will happen? Okay, so while we are waiting for the presenter, no, I think it is important, no, that sampling helps a lot in research, no. It is one of the most important factors which determines the accuracy of your research survey result. So if anything goes wrong with your sample, then it will be directly reflected in the final result. There are a lot of techniques which help us to gather sample depending upon the need and the situation. Maybe, no, you've heard also about the sampling bias. No? The sampling bias occurs when some members of a population are systematically more likely to be selected in a sample than others. So it is also called ascertainment bias in medical fields. Now, sampling bias limits the generalizability of findings because it is the threat of external validity, specifically population validity in other words. So findings from biased samples can only be generalized to population that share characteristic with sample. Now, the causes of sampling bias, no, you can choose of research design or data collection method can lead to sampling bias. Sampling bias can occur in both probability and non-probability sampling. No? In probability sampling, every member of the population has known chance of being selected. For instance, you can use a random number generator to select simple random sample from your population. Although this procedure reduces the risk of sampling bias, it may not eliminate it. If your sampling frame, the actual list of individuals that the sample is drawn from, does not match the population, this can result in biased sampling. So example of sampling bias in a sample random sample, no? If you want to study procrastination and social anxiety levels in undergraduate students at your university using a simple random sample, no? You assign a number to every student in the research participant database from 1 to 1,500, for example. And you use a random number generator to select 120 numbers. No? So from 15 to 120. Although you need a random sample, not every member of your target population, undergraduate student at your university, had a chance of being selected. And your sample misses anyone who did not sign up to be contracted or contacted about participating in research. And this may bias your sample towards people who have less social anxiety and are more willing to participate in research. The sampling bias in non-probability samples, no? A non-probability sample is selected based on non-random criteria. For instance, in a convenience sample, participants are selected based on accessibility and availability. And non-probability sampling often results in biased samples because some members of the populations are more likely to be included than others. Example, you want to study the popularity of plant-based foods amongst undergraduate students at your university. So for convenience, you send out a survey to everyone enrolled in Introduction to Psychology courses at your university. They all complete it in exchange of course credits. Because this is convenience sample, it is not representative of your target population. People who take this course may be more liberal and drawn towards plant-based foods than other at the university. So actually, types of sampling bias, we had self-selection, non-response, under-coverage, survivorship, pre-screening of advertising, and healthy users. So how to avoid or correct sampling bias? Using careful research design and sampling procedures can help you avoid sampling bias. So define a target population and sampling frame, no, the list of individuals that the sample will be drawn from, and match the sampling frame to the target population as much as possible to reduce risk of sampling bias. You just make an online survey, no, as short and accessible as possible. Follow up on non-responders and avoid convenience sampling. This is one way on how we'll be able to correct the or to avoid or correct sampling bias. The oversampling to avoid bias, of course, the oversampling can be used to avoid sampling bias is situations where members of defined groups are underrepresented or undercoverage. This is the method of selecting respondents from some groups so that they make up a larger share of sample that they actually do the population. After all data is collected, responses from oversample groups are weighted to their actual share of this population to remove any sampling bias. So, example, a researcher wants to study the political opinions of different ethnic groups in the, for example, in the Philippines, and focus in different for example, in Mindanao or in Luzon or in Visayas, no, separately, no, but also gathered enough data about the precise conclusions of the entire Philippines, no. They gather a nationally representative sample with 1.5 respondents, for example, that over samples of Mindanao. Let's say for example, random digit dialing is used to contact the household, and disproportionately larger sample are taken from regions with more Americans. Of the 1.5 respondents, 336 are, for example, from Luzon. No, based on the sample size, the researcher can be confident in their findings about that. So weighting is applied to ensure that the responses of this account of 5.6% of the total, and this allow for accurate estimates of the sample as a whole. Okay, so I think that's it for sampling technique.